Happy Friday. How's it going?
Happy Friday. It's going well.
You sound so uncertain of that. Okay.
Well, we're still recovering from finishing our books, so I think we're just sort of in this hazy limbo state with Zhamak. I know you've gone through the same thing, actually not that far in the distance.
Yeah. Welcome. By the way, we got Zhamak Dehghani from. Why don't you just introduce yourself?
Yeah.
I think
Hi Joe. Hi Matt. I'm Zhamak. I work for ThoughtWorks. I'm on sabbatical right now, so I'm not working right now. I finished a book. This is what I did. I finished a book. It lined up perfectly with my 10-year kind of long service leave, and I just straight dived into that. But I must say, it's really hard to kind of orient yourself after having worked, as you know, many hours of the day. You have your day job and then you have your night job of writing the book. And especially that last mile of editorial phase that you're just grinding through the review feedback and edits and so on. It's like refactoring code, not so much the creativity of the upfront, but refactoring of the end. I think it's hard to orient back to a normal life. You have all this time, suddenly you don't know what to do with it, and you're still in the go, right?
I was just telling Matt today, I feel like it's just this weird. I don't know. I've just been walking on a fog all week. I've never felt like this before. I don't know what you went through, but it's bizarre.
So. I started the next thing. I started the next project immediately. I haven't even taken any time off.
Oh man. Well, I guess we officially haven't taken time off either.
Wait, so you got something else, and then we'll have to talk about this.
Yeah.
So, that's awesome. Cool. So thanks for the audience that's showing up here. We're here to talk about data mesh, but I think not in quite the way that you're probably used to hearing it. We want to explore some of the edges of data mesh. And going to keep this pretty conversational. I think Zhamak's also interested in kind of our perspective on things as well. So we'll kick it off. So I guess the basic question that we have to ask you is, what is data mesh?
Mm-hmm. Sure. I try to find kind of novel ways of describing it, but I think data mesh is a thing that you do to get decentralized data ownership and data sharing and data management, particularly for analytical workloads, for processing data to either train your machine learning models or generate reports and trends or do all sorts of analysis. But data mesh is an approach to that, to get to that target state of decentralized ownership and decentralized sharing of data, but in a way that it can scale out, in a way that as we come across new sources of data, new places where data resides, new teams or new organizations that own the data, we can still get value. We can still find access this data reliably and get value from it for analytical purposes. Mm-hmm. What is it, the thing that you have to do? Well, it has some technical elements, architectural elements. It has some social elements, organizational elements. There's all of those things that you have to do socially and technically to get to that place, to that scaled out, decentralized yet responsible data sharing for analytics.
And when you talk about scaling, it does sound like maybe we're talking mostly about the organizational scaling to avoid this classic problem of the data breadline, where organization grows, but you have a bottleneck somewhere where data is just not getting cleansed, not getting transformed the way it needs to be consumed across the company.
Absolutely. It's a social scale angle. Of course, it has technical implications, but the starting point of it is that social and organizational aspect. I think for the last few decades, our emphasis on how to scale data storage, data access, data processing has been focused on the machine scale, right? Mm-hmm. Distributed file systems, parallel processing of the data, separation of compute from storage to scale out those independently. All of those problems of scales were kind of machine optimization issues. I think the layer of scale that we have perhaps largely ignored or disregarded because we just didn't have the biggest cognitive or time bandwidth to focus on it was, well, this data doesn't exist in isolation or independently of the people that are generating and using it. So what if we imagine this future? And I think a lot of our aspirations require achieving this future where you're accessing data that is owned within the organization by different domains. It's generated, managed. Like people who have the context of particular sets of data, they live in different parts of your organization. And even beyond that, if you think at the planetary scale, you have two choices when you have those use cases that goes beyond the bounds of organizations, right? You have this either the medical use cases or customer personalization use cases, healthcare use cases that really go beyond the data that one organization owns. That you need to access data that crosses the boundaries of different organizations, and to get access to that and get value. And I focus on getting value from data, not so much managing the data or sharing the data, like truly end-to-end getting value from that data. You have two choices, right? You have the choice of becoming Google, like collecting, or this alternative future that you're really sharing data the same way that API sharing kind of works, right? Across the boundaries of trust. So data mesh is the other. It is a more decentralized access to data across trust boundaries, essentially, in a responsible and scalable way.
That's interesting. I mean, and you're at ThoughtWorks, and I've nerded out on Martin Fowler's articles on microservices quite often way back in the day. And how much inspiration did you take from, I guess, the microservices approach? What's that?
A lot.
A lot, yeah. Because I looked at it, it's really familiar. Like,
yeah, and a lot. I think. My background has always been distributed computing. So even as a young engineer, I worked on network protocols, for kind of communication. I designed routing protocols. I built systems that were distributed. And then the last kind of decade or so, I went through knee deep or waist deep in kind of digital transformations that were heavily relying on microservices architecture and organizational structure. And I really appreciated kind of the scale problem, that the scale solution, I suppose, that microservices can bring to bear, like considering like Netflix of the world, organizations that we look up to, and give autonomy to people to do their jobs and focus on a cognitive kind of context that fits in somebody's head, right? You don't need a whole tribe to understand what actually you need to work on and what's the problem space is. So that problem of kind of cognitive scale or autonomy and people scale was solved beautifully by microservices. Of course, implementation of microservices looked pretty ugly early days. We built pretty ugly systems, but then over time the technology kind of evolved and made it pretty natural and native and organic kind of to build microservices. But so that inspired me. And if you read the title of, let's say, Eric Evans' domain-driven design, which is another kind of influencer on my thinking, it says hopefully I don't mess this up, somebody can check, domain-driven design, addressing complexity in the heart of software, or something like that. And it came at a point that the software systems were so complex, and organizational, kind of design was complex. You have multi-teams and communication between the teams, that you had to just think about how to scale out software development differently to address that problem of scale and complexity, right? So that inspired me, and I went, okay, is it possible to apply the similar principles, but in an adjacent domain, in a data domain? And if it is, then what does it look like, right? That was the kind of the line of thinking. In fact, I was shocked. In fact, when I started looking deeper into how the big data systems were, or BI, traditional BI, and then kind of big data organizations, analytical organizations were designed, and architecture and the technology, I felt really surprised that we are where we are. I felt like the thinking around managing complexity was around probably 17 years behind what we had done in the software operational space. So yes, a lot of inspiration comes to that, but I have to say, I come with a lot of empathy and kind of appreciation of the complexity of data and accessing data, the way that in operational systems, you can hide data behind operational endpoints and APIs so easily. That's much harder to be done when it comes to access points that are required to abstract, underlying data complexity for analytical workloads. So we still have a lot of adaptation and evolution of that thinking to be applied in the data space, but absolutely the inspiration came from there.
Yeah, and I would say, I mean, one of the things, and you're going to have a much deeper perspective about this than I do, but so certainly correct me if I'm wrong, give me feedback. My perspective on microservices is that one of the major changes was that we started to abstract away the networking details. In other words, we created these systems like Kubernetes or, Docker Swarm further back, said, all right, these systems are going to worry about all the details of where individual containers get deployed. They're going to handle the virtual networking. Software developers don't think about that stuff. You're just thinking about software. And then that allowed us to have this greater team abstraction where you could just focus on these organizational complexities of breaking down really complex processes into smaller pieces. And I feel like we're getting close to that in data. So things like Databricks and BigQuery and Snowflake and EMR, all of these tools make it a lot easier, but there are still some limitations in terms of.
We cover the technology complexities.
Yeah,
I mean,
exactly.
Yeah, and that's. I think to your point, Zhamak, it's sort of like I think the technology is getting solved, and I'll touch on this in a second. But it's the organizational piece is still super challenging. I mean, every organization I think that we deal with, the technology is always the easiest and probably the last thing we talk about. We always talk about like people, process, and then technology in that order. We never come to a company and we're like, hey, you should definitely implement this technology because that'll solve your problems. Like that's reckless. So
yeah, I think Matt, so going back to Matt's point around kind of abstraction of complexity and just focusing on kind of interfaces in a way was a big leap for us to be able to to kind of distribute work and think about independent autonomous domains and so on. The thing that is really different and it's missing and we have to move to that space is that in the case of data, traditionally we are from technology perspective and approach perspective, we are incentivized to co-locate or aggregate or collect data and in fact pay a lot of attention to this thing that we are creating and collecting and not so much pay attention to data could be coming from many other teams and yet we want to be able to run these workloads that requires processing data across. So let's actually focus on those connections and APIs and intercommunication, and let's standardize those. We sometimes forget that the main catalyst for distribution of workloads through microservices was HTTP, was REST, was agreeing that these were pretty good, flexible, yet powerful primitive to get us going. When it comes to the world of data, I feel, yes, we do have, I guess, JDBC, and we have SQL as some sort of a pseudo, relational algebraic language, but is that really enough if you're training a machine learning model across data across many places? So I think there is a complexity around creating APIs that allows this distributed analytical workloads happen, and we haven't been really incentivized. I see how Databricks like taking some steps towards that with Delta sharing and so on, but we are at very early stages of that, and we need it. And I hope the data mesh is the catalyst, and industry forces is the catalyst for us to look at seams and interconnection and communications and protocols as opposed to yet another big system to collect data.
Yeah, this is something Matt and I, we nerd out on this a lot. It's sort of the notion that, data APIs need to be rethought. And I think data integration needs to be rethought. Yeah, with data interoperability, we talk about this for hours because we're super exciting people. But
what do you think? Like this is the exciting stuff.
Well, yeah. So I mean, Matt, we have this idea of the cloud OS. Right.
Yeah. And I mean, Ben Stansel has talked about this idea too, and we write about it some in our book. And that is that we need kind of what you're talking about, Zhamak. We need not only should an organization, well, let's say this, a small organization should not be creating their own APIs to exchange data. These should just be standards, whereas like, yeah, if you're on AWS, this is the standard way in which we exchange data. And it's funny, we kind of have a lot of the components. Like S3 itself is a really great data sharing layer, except that the permission system is still a nightmare.
Exactly.
It's just not, okay,
Yeah.
what about column level permission, row level permission, or even permission on individual data sets and tables? It's just not really set up for that. And, you know, people are still using Hive Metastore, which at this point is really old, to try to manage those kinds of things. Databricks has Unity Catalog. It's pretty new, so it remains to be seen how that's going to go. But like, we need these other layers of management that sit atop big storage.
Yeah, absolutely. I mean, when you think about that, I think that permission and ownership and identity system and access control system is such a key one. When we, again, I always go back to kind of find analogies in services and API world. You know, we had to resolve from kind of a centralized identity to a federated identity with, you know, kind of the different protocols we had around it. And then now even people are moving to decentralized identity. This isn't like the future. It hasn't really happened yet, but it is coming to allow peer-to-peer usage of APIs with access control and authentication authorization baked in, independent of who owns the service, right? So you can authenticate yourself with a completely different third-party service that then allows you to, that federated model, to allows you services of others. So that has to come. But, and it's not a vendor-specific proprietary, even open APIs. This is a, you know, standard, internet standard APIs, right?
Yeah.
For authentication and identity. That's just one piece of rethinking data APIs.
Yeah, I completely agree. I mean, I would say actually like Google, BigQuery, and Snowflake have done a great job of defining a standard data sharing layer with really fine-grained permissions. But if you want to not use SQL and use Spark, then it becomes very difficult.
Yeah.
If you want to go cross-cloud, it becomes very difficult. And so they're not really industry standards. Like I am going to applaud the vendors' efforts on this, but it's like, yeah, we need more interop,
It
not
still feels
just
super
lock
early,
in.
though.
It's early. That's true.
Yeah.
I think the other part of that too is definitional integrity, right? So, you know, so I think metrics layers and semantics layers are becoming like, you know, the cool thing, but it also drives me crazy because I feel like it's at the data warehouse level or data lake, which I think is the absolute worst spot for it. Actually, that needs to be up more at the application layer where everything's being defined at the data layer. And then, you know, but I think it kind of also that though, it also needs to be sort of definitions across the board, like through each stage. So you have a definition.
In fact, like data mesh has this concept of data product, which is one of the most misused, misinterpreted, hijacked concept. And
what is a data product?
I wish I had a better command of language to choose a I don't know, better name. Yeah, so the concept of the data product is basically, as you said, you know, a lot of those affordances, and I love this word affordance, defined by Don Norman, is like the capabilities that an object can give different users or agents in a system based on the abilities they have. So this affordance of, like, for example, providing metrics so that data is understandable or can be evaluated for fitness for different use cases by the users of data. So all of these kind of affordances that need to accompany data for it to be understandable, trustworthy, secure, you know, accessible, addressable. Like I think I've got 8 of them that I said this is non-negotiable set of characteristics that you have to have. That's essentially is data product. So encapsulating data and metadata and code and policy to really allow this domain-oriented, boundary, autonomous, independently, like with an independent life cycle of a data to be easily accessed, understood, discovered, used in variety of modes of access. But one of those pieces, one of those affordances is understandability and trust. So when you kind of peel that back and say, okay, what do I need to accompany with the data so that it is understandable, is you actually land on maybe a bunch of metadata, but you also land on some code that needs to continuously run along with that data to produce this live real-time kind of metrics of, oh, this is the window of time over which this data is being produced, or this is the last updated time. This is the, the completeness as of now or as of yesterday, right? So all of this kind of set of metrics that you refer to that defines quality, integrity. So essentially, to bridges the gap between, where the user is and where the user needs to be to actually trust to use that data and evaluate its fitness. They are part of the data product. In fact, I always think this idea that we have data and then we have metadata is somewhat flawed.
Yeah, we can hit on that too. Yeah.
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 It's somewhat flawed because you're saying, when we make such a statement, we say data, but not have this meta, which is very hard to define what meta is, because you have n levels of meta, like meta of what meta, right? So I actually refrain from that duality of meta and data, and I use the shortcut of saying it's a data product. It means it actually has not only the facts that happened, the data that we aggregated, but necessarily always has to accompany all of the other pieces of information that is relevant to that data for that point of time, for that data to be trusted and understandable and so on. And I call it, then it's a data product, right? And when going back to your point, Matt, that you Joe, that you said, okay, we put this metadata too late, and that's how you get it closer to the source, because next to your source, you have a set of data products that right from the beginning are designed to externalize data responsibly. I
mean, what do most products have when you go to a store? They have like a barcode, right? I wish there was like the equivalent of something like that for data, where it's a contract. This is what it is.
Yeah. Yes. Yes. Data contracts.
Oh, contracts. Let's talk about data contracts. Another buzzword that gets like
carried over from the software.
Data escrows or anything else that we did.
Well, contracts remind me of a different. It evokes a different thought in me. Like when we talk about contracts, I thought about this kind of, in the services world, we move toward kind of consumer-driven contracts as a way of consumers telling the services what do they expect from the service to do. It can't be directly translated to data, and I'll tell you why, but it is an articulation of an expectation and agreement, right, between the consumers and the providers. The tricky thing about data is that it's different, and I think that's why it's just this whole data APIs. It's just such a fascinating space, because there are some funny things about data that are different from APIs, and then yes, there's so much learning from APIs. When it comes to data sharing APIs, actually, I'll turn this back to you. What do you think is the main difference between if we were like putting our heads together and defining these kind of data APIs, and I said, look, guys, there's this thing, consumer-driven contracts for services. Why don't we do that? Why don't we get our consumers define these contracts of what their expectations are from the data? And then, they say that they expect this bell curve, or they expect this, kind of set of fields. And what do you think would be the main difference that we can't just directly bring that idea and concept and apply it to data? What's different about data contracts? Sorry for doing this to you, but I couldn't.
No, this is great. We love these open-ended conversations that take unexpected turns.
I would say if the data exists to fulfill that contract in the first place, that'd be the first place one of the first places I would start is, can I even fulfill your request per this contract that you've set out? So, and that's where I think the big difference is with data versus maybe an API, or an API. Software engineering is very much about a set of like maybe requirements in terms of functionality. Data has the extra layer of being, what is the data, first of all, like what's in it? And then, you can dive many layers into that as well, like context, meaning, types, et cetera, et cetera. But that's, I don't know. I feel like I'm answering.
I think we're dancing around the same area that I'm thinking, but I love
Matt, what you tend to kind of go off into left field with your thoughts. What do you think about this?
I mean, would we relate this back to like expectations, not not to cite a particular vendor here, but just the notion
It's a
of
book
applying.
by Charles Dickens.
Yeah, exactly. Of
So-
applying expectations to data and saying, all right, data system, data source, what do you know about this data? What can you tell me about the distribution? What can you tell me about the presence of nulls in different fields?
Well, but it's
Does
also
it
that, but it's
comply?
also like what is, you know, we always talk about how transformations are really where you're going to get the ROI out of your data. Like, what do you intend to do with it? And so that's also part of the contract. Is it possible for me to even do these transformations that you're requiring, for example, whether that's for analytics or for machine learning, are the features available and is it usable? So yeah, there's a lot of
There's both really good thoughts and answers.
what do you think?
I agree. One thing I would say is that we can't solve in a traditional kind of expectation-driven development of data is that with data, you have these unbounded by unbounded is that for data, you have these future people that will come and look into the past data and have a new set of kind of expectations and requirements and usage for that data, right? Most of the time, we're retrospectively analyzing the data. And if you are developing, to your point, like what is the data that I even have to put in this data set? And if you were just driving that decision based on what the customer or consumers that you know today want, right? You're basically excluding this unbounded set of consumers that are coming in future and looking at the past to get value and discover trends and so on. And I think that's a tricky part about expectation-driven or consumer-driven product.
Well, it's kind of like the difference between like a contract and writing like the U.S. Constitution.
Right.
So maybe the U.S. Constitution anticipated a lot of ambiguity in the future. Like you don't know, but at least there's checks and balances, and maybe that's one way of looking at it, where it's not necessarily a fixed contract, but more a set of fixed, maybe not even fixed, but just kind of guardrails really that can be interpreted. Because sort of the future decision maker might be your Supreme Court, for example.
Well, it seems like maybe when you're dealing with these vast data sets, the limits maybe need to be a little bit softer. In other words, it's not quite like I call it an API, I get essentially a single row, right? I get a single JSON object back. And if it's not compliant with the contract, then it causes a problem. Whereas with data, maybe you just need to send alerts if the data doesn't comply. I mean, one thing we talk about a lot is the fact that data and analytics is very entropic. That is, it changes with outside your control because so much of it comes not only from other teams, but outside your own walls. So to take a basic example, if you're looking at web event data and you want to know something about the user agents you're going to see coming in. Well, those can change all the time. And not only that, but some new botnet can come online and generate all new user agents. And like, good luck as the consumer stipulating what the possible user agent should be.
Right in the contract. Oh, it violated my contract.
Exactly.
And it's like, yeah, that's the point.
Good luck with that.
and for that reason, I think that balancing act of, okay, what do we know about the data as the providers? Is our authority and our knowledge of the context that can design what the data could be and sharing that and balancing that with what the current consumers want and hypothesizing what the future consumers want and like managing the cost and effort of keeping that data and sharing that data and evolving it and evolving it over time. Just that balancing act, such an art. And I think that's the beauty of, I guess, this new role of data product owner. That's my expectation, is like data product ownership by the team, by data domain teams essentially, and its role of the data product owner has to do is like strike a balance between all of these different forces, right? And then the provider of the data becomes has a big say because they have the context, they know a lot about the context, but they can't just ignore the consumer and how the data wants to be used, and they can't ignore the future, that what the future could be, right? So it's I think it's a fascinating job to have.
Yeah, it's a tough job too, right?
It's a very tough
Yeah.
job. Yeah, for sure. Yeah.
I was about to say it's fascinating, but yeah, in fascinating ways. It's fascinating. So,
Yes.
yeah. Kind of back to data mesh, like I think there's I see a lot of talk about data mesh right now, and I think, and in some cases, I'm not sure if people are correctly interpreting it sometimes, or maybe I guess correctly explaining it. Do you find this as well, or maybe it gets a bit misinterpreted or misconstrued?
Yeah, I think yes, I think there is a challenge with kind of understanding it by people that have been for decades in the data space, and they have a you know kind of they have internalized what data management and access to data and what good data should look like, and those internalizations are based on decades of very fundamental assumptions that data mesh is challenging, right? So for those folks to bridge the gap, and that problem is also exacerbated by not having tangible like reference implementations and technologies that natively support this model. So you have to bridge this kind of cognitive gap of coming from a very different system of thinking to this new model of thinking, and to bridge that, and without having like a specific implementation of it, because it's more of a vision and idea, and then implementations are kind of custom implementations at the moment behind the walls. So I think people kind of really struggle to bridge the gap. For example, a lot of the traditional kind of data management thinking is about optimizing modeling of the data for various queries and optimizing again for the performance, right? So the way the star schemas are designed, and kind of that angle of another day warehousing has many different angles, but that particular angle of it. So a lot of the questions that I ask is that, how do I, if the data is distributed across these data APIs through these data products, how do I do a distributed join, or how do I do that effectively? And then my answer is that for us to be able to get to the right solutions, we need to again decompose that problem to, okay, there is a physical layer optimization that we have to do, like the systems creating the right indices and storage, where the locality of the storage and that sort of stuff. That's kind of internal complexity that Matt just talked about, like the technology needs to push down. And then there is a logical layer kind of optimization for this human experience that we have to create, that yes, we can do. In fact, imagine like, what does it take to do the composability of the data across different nodes? Well, the first step is you need to be able to discover where the nodes are that, let's say we want to compose information about customers across 5 different data products. First, you need to be able to discover data products that have something to say about customer. Okay, we did that. Then you need to discover and understand what is it about customer that each of them are storing. One is about order, one is about profile, one is about address, other things. And then you need to discover or be able to correlate customers across different nodes, right? Different data products. So it's an identity system. So that's kind of a logical layer concern that we can then solve for, right? That's not really hard to solve. So I think this bridging the gap is one of the main challenges to understand data mesh. What I find is that folks that in fact have gone through the microservices, that they come from that operational distributed system kind of thinking, and they dabbled with data recently, they have a much easier kind of journey in understanding and internalizing data mesh, because they have gone through this organizational, the social and the technical change together once before. You just have to apply to a new space. So and then the kind of there is a third group of people that are vendors that have been kind of pushed to be almost jolted overnight because of the adopters and the market forces to say, sell me a data mesh product, right? So they have to they've been positioned in a difficult place, that they had a product strategy, they had a nucleus of a set of products that they were solving under whatever banner it was before, and then they have to overnight say, oh no, we are a data mesh platform, or we are a data mesh solution. And some of them maybe do a good job in kind of articulating, okay, what angle I'm solving, and some of them just like search and replace, I don't know, data lake or data mesh. So that leads to this misconception, because when I talk about data mesh to a lot, I hear other folks talk about data mesh, they're really bringing the vendor's marketing message forward, and that's their understanding, and that's that might be misrepresented.
Right. But now there's a book out, so you can just read the book and then learn all about it, right?
That was the only reason I wrote the book. I actually said, I
Interesting.
think in one of the, I don't know, professors somewhere, that I wish I could write this book 5 years from now. But I felt that there was so much noise and movement that I had to write something to say why and what. And then
Yeah.
maybe the how, right? I intentionally stayed from technology because that would rapidly change and make the book kind of obsolete in 3 months. So that, you know, we can go back to it. But unfortunately, a lot of us are just can't read beyond whatever the tweet length is now. What is it? Is it 280 character? How many characters? We don't read more than that.
Maybe it's 140, I don't know.
But
240, whatever it is.
and I remember when you wrote the articles, what was it, 2019? I think your first article came out on data mesh. Yeah, I mean, that exploded on the scene. I was like, it definitely reminded me of like other things I'd seen in data and technology where it's like, okay, it's a big idea. Like this isn't just some like random person shouting at the sky. Maybe that's what you were when you first wrote it, but then all of a sudden people are like, oh my gosh, this is interesting. And so, and then I kind of took on a life.
Before that article, I was for a couple of years, I was
interesting.
Talking behind the doors to my colleagues globally, looking at all the projects we're doing globally, talking to head of analytics, head of data, CDOs, getting their wheels turning, seeing what the problems are. So it was, and I got frustrated enough to, in 2018, I can't remember, or early 2019, to go and give a talk first to see, like, would I get attacked? Can I talk about this stuff publicly? And then I got encouraged to write about it.
Well, I mean, it was kind of on the level of like what Copernicus did or something, where it's like the Earth isn't the center of the of the solar system and so forth. And it's kind of, it reminded me of like on that level in the data world, where it's like, okay, like it was I think perceived as maybe slightly heretical when it came out, and I think in a good way, of course, because that's where the best ideas come from. But it was definitely, it splashed on the steam. Walk me through that real quick, the evolution of the idea. So you started talking about it with your close colleagues, and you wrote the articles, and then tell me how the whole idea
saw the problem firsthand. So I had two kind of concurrent positions within ThoughtWorks. So we're a global consultancy company, but we build software, platforms, digitalization, organization transformation. We do all of that. We're super hands-on. So our hiring process is fairly tough. So we get pretty good, really good kind of software engineers and practitioners. And we pride ourselves in, as a consultancy, in software excellence. So we have had traditionally a lot of innovation coming at ThoughtWorks. So I had access, I guess, to a great mind hive, within ThoughtWorks. And then I am part of the tech advisory board for ThoughtWorks that generates an article we put out twice a year called Technology Radar. So what it is, in fact, is a sample of all of the projects that we are executing globally. Let's say 10,000 people, like, writing code or building software or doing data projects. And then we gather information about technology that works or doesn't work or need to be assessed or is awesome, should be, adopted. And we've discussed that like vigorously, like over the course of 5 days with, 15, 16 people in my position. And then we write about it. We filter them out and then we write about them. So I was seeing what the state of adoption of technology is and what the tools we're playing with, right, in our toolkit. And it was really shocking for me, again, that the state of maturity of some of the data technology. On the other hand, I was a portfolio director for I'm in San Francisco for West Coast of US. What it means is that I get visibility to all of the inbounds and all of the projects we do for our clients, at least in the West Coast. And as you can imagine, again, I work with fairly technically advanced companies here, right, that have invested in first generation, second generation, go to cloud kind of data platforms. So I was seeing that they were struggling with scale. Like they would hire the most amazing head of analytics and data science team, but they can't do anything because they still don't have access to trustworthy data. Right? Yeah. So then I I went and the third angle of it was people, like hiring data engineers, hiring specialists. It was just an Achilles heel. Like we couldn't get this, and I'm sure a lot of other companies have this recruitment issue. So I went and really looked deep into implementations, architecture, the challenges. And I went, okay, this is complexity at the heart of data at an organizational level, directly related to technology and architecture. And we solved this problem. We solved this problem 10, 12 years ago in the operational world. We were exactly where we are today with digitalization that happened with web and mobile and all of that with back in, 2010s, around kind of 2010 with microservices. So why can we learn from that? Let's learn from that and bring that experience to data. And then I started kind of picking, the great minds' brain as to see who responded. And some were excited, some were, no, this cannot be done. This is heresy. Like I was told actually by some of my colleagues to not publish the article.
Oh, really?
Yeah, I didn't. It was I guess controversial, like even to do that. So I put it out with the knowledge of I may get ridiculed or attacked or whatever. But I think what happened was the problem that I was articulating, I was seeing, wasn't just unique to the West Coast of the US. It was pretty much global, and that empathy for the people and the problems that all kinds of roles of people were seeing touched people's hearts, and a lot. Then the feedback that I got was, why didn't I think of that? Like that seems kind of rational. And kind of we went from there to, okay, let's actually get real about this. Let's with some of these ingredients that I brought to Data Mesh was already being implemented and tested on some of our clients, and say, okay, let's actually start implementing this. So the next 3 years was about just refining and building and hit your head against the wall of technology and organization. And this is just the beginning. This is just the beginning.
Yeah, I don't know what your take is on like what the timeline is for like, broader adoption of data mesh, but I think it really feels like it reminds me of the arguments with microservices many years ago, where it's like, oh, that's the monolith people were like, oh, that's stupid. Like, why would you ever do that? But then but now it's sort of the I think it's pretty standard in a lot of software engineering practices. But it also feels like in data's in this weird spot where I feel like in general, software engineering practices are getting adopted. Data ops is a big one. Finally, you got data observability, all these other things, all these practices that software engineering has been doing for a long time. And in fact, when people ask me where's data going, and I'm like, why don't you just look at what software engineering has been doing, and like pretty much if there's something there that hasn't been done, that's probably going to get adopted at some point.
Well, we've quietly seen some major technology changes too. I mean, one of the motivations for centralizing data is that you would sign this multi-million-dollar contract for like an MPP system, a lot of money, and it was always space limited, right? You were always fighting with space and resources on that system. So you'd have this centralized like data warehouse team, like, all right, here's what can go in this system. We have to get rid of these tables because we're overflowing.
It's like a tiny home.
It was basically like a tiny home. And the technology change is that now with the cloud, it's not that you have a distributed system like an MPP, it's that you have a distributed system of distributed systems. In other words, you can have many different clusters and you have virtually unlimited storage. And so that this need for gatekeeping kind of disappeared, but it's taking a while for the organizational possibilities to catch up to that reality. Like we don't have to centralize everything anymore because we don't need one team to own that entire system, be it Hadoop or Teradata or whatever.
Yes. Yeah, agreed. It's just that, I think for the primitives, the programming primitives, data management primitives, the primitives of the systems that we need to work with need to level up to speak to that kind of decentralized model of working with data. The primitives are not there yet.
They're totally not there yet.
Yeah.
And that's where I think there's a lot of, I would say it's kind of, we're just almost blindly copying software engineering too. It's like, oh, that worked here, so let's apply that to data. And it's kind of like this almost like lift and shift in a way. I think we're in absolute agreement. We should definitely talk offline about, I think, some deeper thoughts we have on this, because it's we're basically trying to rewrite this whole treatise right now and just the whole world of interop, and it's
and I would put a question out there: is there this whole data versus app, kind of like duality that we have? Like, I'm an app developer, I know how to deal with my database and data, and that's a model of working that I have. And you're a data person, you're doing big data analytics and that. And as and usually it worked in the past because the flow was one way, right? You get the data from those applications and then you collect them somewhere and you start doing analytics on a downstream or creating models.
Yeah.
And this feedback loop is now tighter because the analytics and data gets embedded has to get embedded to those applications to be the applications of the future, right? They become data driven. So as that feedback loop gets tighter and the teams that are involved need to, be more cross-functional. Sure. Does it make sense?
No, it makes total sense. And I don't know if you were just like listening to our other conversation just a bit ago. Yeah, no, we wrote about this in our last chapter in our book. We're thinking, okay, so like, what's the successor to the modern data stack? Like, because when we kind of said, I think the modern data stack was really good in that it democratized to a large extent exactly what Matt described, which is these hyper expensive, very static data warehouses, and really brought this technology to the masses in a way that's consumable by the credit card. It's easy to set up, easy to tear down, et cetera, et cetera, et cetera. That I think was the big. If I were to look at what the modern data stack contributed to the world, it's more of a behavioral pattern and an accessibility pattern. But I think you're absolutely right. So what we thought was a successor is what we call the live data stack. I don't know, buzzword or whatever, but it's like bringing the application layer closer to the data in almost a seamless way. Because it's like, why does the data warehouse have to sit at the center of everything, right? That worked for some things, but I'm questioning, especially with the popularity of streaming, for example, real-time automation, whether heuristically or with ML, like why do we need these sort of bottlenecks when really everything can work in almost a seamless fashion? And what this also means now is, and one of the things that we, with data mesh, it's like the data team, I think the data team and the software teams are going to be much more unified at the end of the day as a result of this, because it seems like a very artificial distinction.
The modern data stack is an interesting one, because if you think about from my perspective, I could be completely wrong, but I feel what we did was we deconstructed those big, data systems and overlaid a bunch of like open, useful tools and technologies on top of a data processing management model that was still based on the previous paradigm. So we still have data extraction, data ingestion, data movement, data processing, data storage, right? So it's still that move data from one end and process it and then transform it and put another, the ETL and storage model. But now we just broke down the big monolith and a proprietary system, and we came up with lots of smaller system that is still beautifully fit into that last paradigm. The future, I think, the next generation modern data stack, I would hope, of course, I'm totally biased on the data mesh model, is recomposing perhaps those tools or a new set of tools that work on a different meta architecture, right? It work on kind of a mesh and distributed architecture more natively. But I think they had as you said, that previous, like the modern data stack we call today, had a big role in democratizing those activities.
Sure.
And transformation.
Well, and in fact, what I see is almost a back to the future moment in some ways, where I think microservices and data mesh are actually going to be the same thing in a lot of cases. Because as you tie it back to the application layer and data is sort of integrated in the app, then you kind of back to where you originally got your inspiration from. Maybe, I don't know. It's hard to predict the future, but that's one very likely scenario, I would say.
Yeah.
Very likely or likely. I don't know.
I think it's very likely.
To say. Yeah.
I think there are technology tools you need that aren't being used right now in the microservice world. So for example, one thing we talk about is you can't really serve, because of the cap theorem, you can't really serve transactional workloads and analytics workloads in the same database. But what you can do is set up another layer that's pretty seamless to the user, so they don't see it, that just you stream right into an analytics database. And I think that's the kind of integration that's going to enable this.
Exactly.
And then,
I call those, like in the data mesh language, like we have this concept of kind of data product as a very primitive concept, like element, basic element of your architecture. And some of these data products, whose job is actually providing those analytical data processing or data access APIs and maintaining that data, but some of those are kind of aligned to the source. So they are sitting as like a satellite kind of entity right next to your application and application database, and you choose your model of integration between those two. But those are aligned to your source data, and the life cycle is more aligned to the changes in the life cycle of your data versus some data products that are more downstream and aggregate and or more downstream and kind of fit for purpose for different use cases that you have. So that's one future, right? As you said, there's another layer or there's another entity kind of satelliting around your applications, or maybe, I don't know, Google's of the world come out with this magnificent universal database technology that you didn't care about. But I even push back on that. I said, even if maybe I'm not creative enough in my thinking, but I think even if we have as a physical layer, right, that universal transactional analytical workload can be all represented as one, still at the people level, the concerns of an application developer in terms of storage and sharing the data are very different from the concerns of a data product developer that thinks about the analytical use cases. So I think at the human level, you still have those separations, but they just come and work very closely to sit next to each other.
Yeah, and one thing we talk about a lot is the need to rethink data modeling. And so I think what tends to happen right now is application developers only in many cases, think of data modeling in terms of object-oriented programming.
Well, it's like a unit test.
It's a unit test, and also they create objects, and then ORM creates the schema for them. And then the analytics people then have to untangle a big mess of schema that's not intended for analytics. And I think the future is that those teams sit together. You've got your analytics on the cross-functional team, you've got your software developer. They say, okay, what data model is going to serve this data product? Meaning it serves the transactional use case, but it can also flow directly into analytics in a way that's very useful.
But then the nature of analytics, we think also needs to change. I mean, analytics typically is meant to answer, right now with dashboarding, it's like what and when type questions. Think about like, what are you going to do with that if you get it? Like, in my opinion, a lot of that should just be automated. Like, what action are you going to take?
Yeah, the human user needs to become a machine that acts upon. It takes an automated action. I think that the what and when and the trends and the human looking at the data is still going to remain as an important digital experience of people. I don't really this separation of, oh, I have a bunch of dashboards here I look at. I feel that experience in future should change to, I'm interacting to do my job. I have a digital experience that go through this, steps that I need to do my job. And part of that digital experience could be dashboards and analytics. And that's how the analytics would get closer and closer to that digital user experience. Right? So it's not a separate thing, right? And part of that, and you're right, that probably a big subset of those human, okay, I looked at this data and then what am I going to do with it, right? Becomes automated actions that look back into those applications.
Right, because it focuses, then analysts can focus on why type questions, like why is something happening, right? That's diagnostic and prescriptive. And so there's just a lot of cycles. I think there's a lot of ceremony right now that we wish wouldn't happen. But that's I guess why we're all kind of heretical in this chat.
I'm cognizant of the questions that are coming. Do we have time to answer?
Yeah, I'd love to. And we can go past it too if you like, or whatever time it is. I mean, let's actually start. These let me see here. Actually, sorry, Scott, because he had the first question here, and it was a good one.
Is that my friend Scott? Which Scott is this?
Scott Taylor. Not Scott Harleman.
I think I owe Scott Taylor an apology and a bunch of responses that I haven't responded. It's just I haven't had a chance. So I'm sorry.
So Scott Taylor, check your DMs. But he asks, you talk and write a lot about analytical data, but how does data mesh help operational data?
Yeah, I think this was just the conversation we had, right, a minute ago, that you have your applications, that the concern of applications right now, let's say you have a payment service or something like that. The concern for that operational data to perform the operation of payment is, well, I just made a payment. Did the transaction complete? Did it fail? Did it success? Let's just store the state of that transaction, right? That I just made a payment. That's pretty much like keep the current state and retrieve the current last state, and that's pretty much it. A lot of writes, a lot of small reads, and concurrent updates and things like that. When it comes to analytic. And I know this is a very fuzzy boundary, and I'm not trying to say like there's a very clear boundary, but in my mind, when it comes to analytics, it's usually a lot of reads. So large reads, I want to see the trends of all of the payments of all of the users over a course of a very long time, since infinity, from the beginning of time. And I want to be able to exploit patterns in that, whether I'm creating, I don't know, some sort of a regression model to improve what part of my payment operation needs to be optimized, or I am showing a trend where the most payments have failed at what time and when, and how application updates affects the payments. Like there's a ton of kind of analysis that you can do on that data. So the nature of that access is different than what data mesh tries to solve is close the gap between those two. So create a model that allows the operational data become accessible for those analytical use cases by closing the gap between ops, I'm an app person and you're a data person, by generating these data products and owning them by cross-functional team. And every data product can be participating in a global analytical kind of query independently and autonomously.
And another thing I think about here is this new generation of streaming analytics systems that kind of crosses the lines between operational analytics. So, for example, Apache Beam or Apache Flink, where you can use windowing and say, all right, I want to look at the last 5 minutes continuously and look at statistics. And then if statistics go out of bounds, then I'm going to create an event that goes somewhere else, maybe in my application, to trigger something that happens. That's where things start to get really interesting in terms of creating new types of data products. In fact, I would say, you think of your real traditional data products like Uber, where Uber is a key part of the experience. Presumably, they're already doing all kinds of things like this to set prices, to adjust where drivers go, that kind of thing.
Yeah, I am a big fan of kind of processing of flow-based programming or flow-based processing of the data, or stream processing, we call it in the modern days. Sometimes people get kind of conflate the stream processing to like event processing and Kafka and so on. What I really love about stream processing is that you have this fairly flexible model of data processing by this concept of windowing, right? So your window of time could be as small as a snapshot moment in time, an event, or your window of time could be larger. It could be days, or it could be hours or minutes, or whatever the window of time is. And that's and you're continuously just processing these windows of time. And of course, that affects how you even make calculations, like a standard, something as simple as a standard deviation. You can write that formula, actually encode that formula in two different ways. One way is like, give me all the data and I do a standard deviation for you. Or you can say, actually, I'm going to keep the sum and the number of counts and like a few different parameters, and I can, at any point in time, I can give you a standard deviation. So I think that concept of flow-based and stream processing is a super powerful and beautiful concept, because it removes this kind of dichotomy of like batch versus
right,
and you just have one model that is flexible to do just expand, or shorten your window of time. I love it personally.
Actually, I'm going to ask another question that I thought of earlier that's near and dear to Scott's heart, I believe. And that is to throw out a very enterprisey term. Okay, so you have this notion of master data management. And it goes back to what we were talking about earlier. Like, you have to manage IDs across all these different domains, for example. Does data mesh make master data management more important? Or is there some different paradigm that we should be using to manage IDs across all these different kind of silos, right? But silos that are meant to work together now.
Yeah, I actually talked about this in one of the webinars presented. I think the objectives of master data management remain, like having a consistent kind of understanding of what are those master data key business concepts within the organizations, and have a way of kind of correlating that across domains. That remains, right? You want to have, kind of a global understanding of your customer, no matter where the touch point with the customer is, whether you're thinking about customer in marketing domain or other domains. However, what changes with data mesh is that traditionally master data management has done centrally. You bring all the data into some master data management tool, and then we create this hierarchy of entities, and we harmonize the data and rationalize and all of that, and we give you one ID. And that's quite late downstream, right? In the value stream of the life cycle of the data in your organization at the organization level. So what data mesh encourages is to achieve the same outcome, but do that in a distributed fashion, in distributed architecture. How distributed architecture achieves consistency and harmony. So there's no system to go to buy, at least right now. But you have to think about, okay, this notion of data products that every domain can produce, there are a set of cross-functional requirements or standards or governance, and that goes into the concept of like kind of federated governance. There are some characteristics of these data products that need to be consistently defined and applied across the organization. And one of those characteristics is perhaps the unification of IDs, an ID system where the customer information is exposed from an order domain or marketing domain, globally assign these IDs. And again, global ID management itself, you can have a distributed model or you can have a centralized model for the ID management. And you can kind of continue this trend and say, how can I achieve composability and linking customer information across different domains, while doing that without centralizing the data itself and centralizing the harmonization process of the data itself.
It's almost like you need an EDI for something like this. EDI, what is it? Electronic data something interface? I mean, it's like basically a way that like retailers, for example, keep all their ordering systems and everything in check. So it's like, you're consistently getting the same data because it's, imagine you're like Walmart or something, right? Like you have thousands of vendors with like thousands of SKUs. How are you going to keep track of everything? And I think
exactly. It's standardization of IDs. Yes.
Mm-hmm. Yeah. Interesting.
And you have to bake that like shift left, like the data mesh shift left a lot of when you think shift left in terms of life cycle of the data from the origin to the consumer. So left to the origin as much as possible.
Left to the origin. That's interesting. Cool.
So just to follow up on that real quick. So basically we're saying that like master data management, common IDs, it does require some centralization. You do have to have, someone has to decide what the customer ID is going to be, but it's collaborative. In other words, you work together across teams to make this happen. And it's not as command and control as it used to be in the old days where you have a central entity who says, this is what everyone's going to do. It's kind of this more open process.
Yeah, anytime we want to agree upon something, you have different algorithms to achieve consensus, right? So you have to have some sort of a consensus mechanism to agree that this particular ID is the same customer that we recognize in the other domain. And sometimes for those consensus algorithms, you need a centralized entity to make that call. Sometimes you vote, sometimes, there is like different consensus algorithms for that.
That's really interesting. Sorry, my dog's going to town upstairs.
She's excited about it.
Alarm clock, apparently.
Yeah, she always does this at the end of the show. She seems to. Yeah, the kids get out of school from the Montessori school, and she just keeps barking at all the parents that walk by. Well, cool. I guess it's probably a good place to wrap then. Loved having you on the show. Love to have you on again. I think we could probably keep talking for hours. Do you want to promote your book, or how can people find out more about data mesh?
Don't Google it because you get all those ads.
Oh boy, really?
If you Google, I'm sure you get like a ton of advertisements of buy my product or buy this other product.
Wow.
If you, I don't know, if you want to hear from the horse's mouth, you can go on Amazon and look for Data Mesh book, and there's Data Mesh, getting value, data-driven value at scale. So the O'Reilly book, if you have a membership at O'Reilly, you can access O'Reilly. If you want free access to just peek into the book, ping me on LinkedIn or Twitter or somewhere. I share a link that gives you free access to O'Reilly platform for, I think, a month. I'm not sure exactly how long. And that gives you enough time to hopefully go through the content of the book. So that's, I think that's one place that I would encourage people to get started.
It's a great book too. We've been reading it, and it's actually really well written. I think it's one of those books that's going to go down as like one of the classics in the tech and data industry. And I'm not just saying that because you're here, but it's actually really good. The ideas are fantastic. So
I am a very self-critical person. I held the book for 30 seconds in my hand, and I went, oh my goodness, this can be fixed and this can be improved, and images were grayscale. So
Oh boy.
great to hear that from the audience. It's read easily, and hopefully it's helpful.
No, this is one of the classics. I've read a lot of tech books, and it has the vibe of like, this is something that's different, something that's going to be, it's going to hold its weight, and hopefully you get a chance to revise it in a second edition with all the things. I know that it's the same thing. Our book, we just submitted it to O'Reilly this week, and we're just like, crap, we need to add in these other things. Dang it! It's like clawing back. Like, hey, can we add a couple things in there?
Is your book now already published, available on Amazon, or is coming?
It's just going into production, which means that it's heading into proofreading. They're converting it into O'Reilly native format from Google format. We're going to have to, proofread it ourselves.
Your work is not done. You're not done yet.
No.
Oh, thank you.
The advice for us, having gone through the process.
Yeah.
Congratulations to get to this point.
Thank you.
Thank you. Yeah, and congrats to you. You know how hard it is. Well, maybe we'll send you a copy for early preview, so
I appreciate
you can look at it. So
Yeah.
awesome. Well, thanks to the audience. Sorry we didn't get to a lot of the questions. I think we're just having so much fun talking that we just kind of lost track of time. But again, thanks again for being on the show.
Thank you for hosting me. Thank you for sharing your platform to get the data mesh word, out there. So I'm very grateful.
Anytime. All right. Have a good one, Zhamak.
Take care.